Calculating average isotopic mass given the relative abundance of each isotope of an element. Given the relative abundance of each of the isotopes of oxygen, you can calculate the average isotopic mass of oxygen. I looked these values up on the internet. They did give more exact masses, but typically when we do calculate this, we just use the mass of the isotope as calculated by adding the protons and neutrons in that isotope. The first thing you're going to want to do when you do a average isotopic mass is convert the percentages to decimals. Because a percentage is multiplied by 100 in order to deem it a percent, you're actually dividing by 100, or because I'm kind of lazy, all I do is move my decimal place at 2 to the left. So in this case, I'd have to add a 0, and in this case, I would also have to add a 0. And it's a common error that students make, that they don't add that 0 in, and then they get weird numbers. The next step is to take the mass given of each isotope and multiply it by this decimal. So I'm going to have to use a calculator because I'm not that good at math. And all I'm doing now is multiplying 16 by the relative abundance as a decimal. And what we end up with is 15.9616. And I'm going to continue that for each of the different isotopes, not leaving out the zeros because then we're going to get really weird numbers. So 0.000646, and then the last one, the 18, we're going to have to multiply by 0020, and we end up with 0.036. Not very good at writing with my finger. The next step is just to add those up. And that's all you're doing, is adding those numbers together. Don't divide by anything, don't multiply by anything, just add those numbers up. And the number we get is 16.00406. And that is the average isotopic mass of oxygen using the naturally occurring isotopes and their abundances. To make sure that you didn't make any errors, look at the number you're given, and you really want to be sure that it's somewhere between the lowest and highest masses you're given. It's a good indication that you're wrong if it's higher or lower than those numbers. It should also be skewed toward the one with the highest relative abundance. In this case, oxygen 16 had the highest relative abundance, and you'll see it's very close to 16. And it's not much off, not much off from that, since the other abundances are so small. So that's how you calculate average isotopic mass.